Hello guys, welcome to this lesson. If you are new to my channel, kindly make sure you subscribe, you like and you share the videos. Without wasting much of our time, let's move into what we have in this lesson. In this lesson we'll be discussing about systems of linear equations. When we're talking about linear equations are equations of the form x plus y plus z equals b, where b is a constant, and in linear equations the highest power of the unknowns is 1. So when you're having x squared, y squared or z squared, that's no longer a linear equation, then that's a quadratic equation in the case of the power of 2, and when it is greater than the power of 2 it becomes a polynomial equation. So make sure you don't mix up the equations. So when we're now talking about system of linear equation, then that means we are not having a single linear equation. It means it comprises of two or more linear equation. So for example, let's say we're having an equation of the form uh, ax plus by plus cz equals to let's say equals to d, and we have an equation ex plus fy plus gz equals to h, and so on like that. Then it's already a system of linear equation. So what are the methods in which we use to solve linear equation? The first method in which we'll be discussing, there are several methods, but we will only be limiting ourselves to 4 methods in this particular course. But in subsequent courses we'll be discussing about the other methods. So we'll be treating Gauss elimination. We'll be treating Gauss elimination method. We'll also be treating Cholesky method. We'll be discussing about pivotal condensation. We'll also be discussing about Gauss-Seidel iteration, Gauss-Seidel iteration. And lastly, we'll be discussing about the Jacobi iteration. The Jacobi iteration. So I want you to take note that these two methods, Jacobi and Gauss-Seidel, are indirect solutions or are indirect methods. They are indirect methods of solution. There are only the two methods in this particular list that are solved using iteration. That is, you are going to set an initial value, then you iterate till you get to a particular point where your values converge before you finalize your solution. But in most cases it might take long before your value converges, so you just be restricted by the examiner that's taking so step. That is, the examiner might want you to perform 3 iterations, 4 iterations or 5 iterations and the likes. So I already said this is indirect method. These two are indirect methods, while the rest are direct methods. So having said this, let's start with one of the methods, which is the Gauss elimination method. Then we'll be discussing about the other methods in the subsequent lessons. Let's talk about the Gauss elimination method. Let's talk about the Gauss elimination method. Let's talk about the Gauss elimination method. The Gauss elimination method Gauss elimination method. So without wasting much of our time, let's just start with an example. Let's say example 1. Example 1. So this example tells us to solve for the unknowns, that is, solve the system of linear equations, which says minus 3x plus 11y plus 7z equals 2. Then the next equation says minus x plus 5y minus 3z equals 1. And the third equation says 3x plus 3y minus 3z equals minus 1. So let's number this equation 1, equation 2, and equation 3. We are numbering it for it to make our work easier, for it to make our work. And you can see this particular system of equation is a what? Is an equation, the system of equation consisting of 3 linear equations. So without wasting much of our time, let's move into the solution of this. So I want you to take note that your Gauss elimination method is just like your simultaneous equation, where you'll be using your elimination and substitution method. Same thing applies to Gauss elimination method. It's like we are combining the power of that is, we are combining the effect of both elimination and substitution method. Both elimination and substitution method. So the first thing you need to do in Gauss elimination method is that we try to eliminate the unknowns one after the other. So let's try to eliminate x first. So you choose one of the equations, one of the 3 equations as your reference. So let's choose equation 1 as our reference. And what is the coefficient of x in equation 1? The coefficient of x in equation 1 is what? Is minus 3. So you try to modify the rest of the equation so that it can match the coefficient of x in equation 1, so that you can easily eliminate that unknown, which is x. So how do we modify equation 2 so that it can match, or so that it can be uniform with equation 1 in terms of the unknown x? So what's the coefficient of x in equation 1 is minus 3, and the coefficient of x in equation 2 is minus 1. So what do? Let's multiply equation 2 by what? By minus 3. So it becomes what? It becomes plus 3x. Then you can easily add equation 1 and equation 2 to eliminate x, because minus 3 plus 3 is what? Is 0. So multiplying equation 2 by what? By 3. By minus 3. Rather, multiplying equation 2 by minus 3. Multiplying equation, because it will make it become plus 3x. So when you multiply that by minus 3, what do you have? You have plus 3x minus 15y plus 9z equals minus 3. So let's call this equation 4. Let's call this equation 4. Then what about your equation 3? How do you modify it to be similar to equation 1? As you can see, you don't need to do any modification here. It's already matching. As you can see, you have minus 3x and you have plus 3x. So you can just add both, then it will eliminate. But just let us see equation 3 times 1. It will still remain the same. Equation 3 times 1. So you have what? You have plus 3x plus 3x plus 3y minus 3z equals minus 1. So let's call this equation 5. Let's call this equation 5. So how do you eliminate? You add equation 1 and equation 2, and you also add equation 1 and equation 3. So add, make sure you are showing your workings the way you're doing it. Anytime you're solving a question, make sure you're specifying those steps so that your examiner can easily read what you're doing without stressing him or herself that much. So adding equation 1 and equation 4, adding equation 1 and equation 4, adding equation 1 and equation 4, adding equation 1 and equation 4. So what do you have? We have 0 because this and this has eliminated. X in equation 1 and equation 4 has been eliminated. So when you add 11y with minus 15y, what are you left with? You are left with minus 4y. And also when you add 7z and 9z together, what are you left with? You are left with 16z plus 16z equals minus 1, equals minus 1, equals minus 1. So let's call this equation 6. So same thing you do to equation 5. You add equation 1 and equation 5. Adding equation 1 and equation 5. Adding equation 1 and 5. So you can see x has also been eliminated, and if you add 11y with 3y, that gives you 14y plus 14y. If you add 7z with minus 3z, that gives you 4z. And if you add 2 and minus 1, that gives you 1. That gives you 1. So let's call this equation 7. Let's call this equation 7. As you can see, x has been eliminated. You are left with y and z. You also try to eliminate another unknown. So let's try to eliminate y. Let's try to eliminate y. Let's try to eliminate y. So how do you eliminate y? You check the coefficient. As you can see, there is no common factor between 4 and 14. So what do you just do? Just multiply equation 6 by the coefficient in equation 7, and also multiply equation 7 by the coefficient in equation 6. So let's say equation 6 multiply by 14. Multiply by 14. Multiply by 14. So we have what? Minus 56y plus 224z equals to minus 14. Equals to minus 14. So let's call this equation 8. Let's call that equation 8. Similarly, equation 7 multiplied by the coefficient in equation 6, and that's what? And that's 4. That's 4. That's plus 4 times 4 times 4. So we have what? Plus 56y plus 56y. And you can see if you just add the two together, then it cancels out. It cancels out. So you just need to check the sign at the front of each coefficient. Then you now see that which one will be more easier, if you are multiplying by minus something or you are multiplying by plus something. Which one will be more easier to eliminate? We notice that it will be more easier to eliminate when you multiply by positive. So as you can see, you have plus and minus, then if you add together, it cancels out. It cancels out. So when you multiply 4z by what? By 4, what do you have? You have 16z, and if you multiply 1 by 4, you have what? You have 4. So let's call this equation 9. Let's call this one equation 9. So we can now see we can easily eliminate y. How do you eliminate y? You add equation 8 and 9. Add equation 8 and 9. Adding equation 8 and 9. So this becomes 0. This becomes 0. And if you add 224 and 16, what do you have? We have 240z. 240z. And if you add minus 14 plus 4, you have what? You are left with minus 10. Minus 10. So how do you solve for z? Divide both sides by 240. Then you have minus 10 divided by 240. Minus 240. And that gives us minus 1 over 24. So if you want to write that in decimal, what do you have? You have minus 0.04166. So we can see that we have been able to determine one of the unknowns. So what do you now do to get the remaining unknowns? You do a back substitution. You perform a back substitution. Perform a back substitution. Let me try to erase this so that we can be able to use that to perform our back substitution. Let me try to erase this. So we have been able to determine z. So you are just going to pick one of the equations that is having two unknowns, so that you can easily solve for two unknowns, for the remaining unknown. So we have been able to determine the value of z. So we can just recall, and as you can see, before I rub it off, if you are following, you can recall our equation. You can recall our equation 6. In which we have eliminated x from it. So our equation 6 was minus 4y plus 16z equals minus 1. If you are following us. So, and we got our z to be what? To be minus 1 over 24. But z was equals to minus 1 over 24, right? Then if you put that into equation 6, that will be minus 4y plus 16 times minus 1 over 24 equals to what? Equals to minus 1. So if you do this very well, you'll be left with minus 4y. Equals to minus 1 plus 2 over 3. You will simplify everything here and you take it to the other side. So if you do this very well, minus 1 plus 2 over 3, that should give us minus 1 over 3. Then divide both sides by 4. Then y gives you what? 1 over 12. So that in decimal form should give us 0.0833. So I've been able to get another unknown, which is y. So we can also substitute those two unknowns into an equation containing 3 unknowns. So let's recall equation 1, because equation 1 is having 3 unknowns. Let's recall equation 1. Recall equation 1. Let's recall equation 1. Recall equation 1, which says what? Minus 3x plus 11y plus 7z equals to 2. So putting y and z into this equation, what do you have? You have minus 3x plus 11 times 1 over 12 1 over 12 1 over 12 plus 7 times minus 1 over 24, right, equals to 2. So if you solve this very well, just to not to waste our time. So your x, just do that with your calculator. Your x should give you minus 11 over 24 minus 11 over 24 should give you minus 11 over 24. And you can try to check. How do we check? Substitute all your values of x, y, your value of x, your value of y, and your value of z, into any of this equation, into any of equation 1, equation 2, or equation 3, to check if it's going to be equal to this constant. And if they are equal to this constant, then you have not done any mistake, then you are on track. So in the subsequent, that will mark the end of this lesson, and in the subsequent lesson we will be discussing about probably another example on Gauss elimination method, or we move to another method of solving system of linear equation. Tutor Bosun is here. If you are here to subscribe to my channel, kindly make sure you subscribe, you like, and you share my video. Thank you guys.